Hello, and welcome to Astronomy 100. In this video, we're going to continue our discussion of stellar evolution, and we're going to focus in particular on the process of star formation. In our previous video, we talked about how the material that makes up the stars, the mostly hydrogen with a little bit of helium, is present between the stars, and we called that the interstellar medium. And in this video, what we're going to do is show how all of this material can come together to actually make the stars. So let's start with this picture here on the right. This is a typical galaxy. In particular, this galaxy is called M51 as its official name. Its nickname is the Whirlpool Galaxy, and it's a very famous example of a typical galaxy. The reason why I'm showing you this is because it's very reminiscent of the shape and the size of our Milky Way galaxy. Now, in a spiral type galaxy such as the one you see here on the right, this is a composite of two separate images. One image is showing the normal view of this galaxy that you would see with your eyes, and that's the part of the galaxy that shows all the stars. So all of this white, almost looks like it's a foggy, fuzzy cloud. All of this white material is actually many, many, many stars. This galaxy may have 200 billion stars in just this galaxy alone. So this is just countless numbers of stars that form into a spiral shape. Now, the pink parts, you'll notice, is the same color that the element hydrogen produces. So this very specific shade of pink is the color that hydrogen atoms are capable of producing. And what you'll notice is that these pink clouds are fairly specific. You'll notice that they seem to be very concentrated areas of hydrogen material in the form of clouds. But notice how they seem to be all up and down the arms of the galaxy. And you don't find many of these clouds between the arms. Notice there's some stars and some dust, but really none of these pink clouds. Now, the reason for that is because it is the force of gravity that creates the spiral shape of a galaxy. And in a future lecture, we'll talk more about that. But gravity causes a galaxy to take on the spiral shape that we see. And gravity is also the force that causes these clouds to become stars. Remember, gravity's job is to take things that are big and to make them into things that are small, or to take something that's far away and to try to bring it closer. So these pink clouds are pockets of hydrogen gas where gravity is starting to make these clouds form into stars. And so the connection is that gravity forms the spiral shapes of these galaxies, and gravity is also the force that is causing these clouds to form. And so anytime you see these pink clouds, you can assume these are places where stars are forming. We call these sometimes stellar nurseries. Now, the problem is that this galaxy is very far away, and even with the most powerful telescopes on Earth, we can't see these clouds with a great amount of detail. So I'm going to cheat a little bit. What if we could take one of these clouds and see it up close? But the way we're going to actually do that is we're going to switch to an example in our galaxy. So this is a cloud in the Milky Way galaxy that would be very much like one of these clouds. But since it's our galaxy, we can see this cloud with a tremendous amount of detail. Now, what I want you to notice is that this cloud has a shape. And in astronomy, we often nickname these clouds based on their shapes. It has an official catalog number, but the nickname for this cloud is the Heart Nebula because of the shape. You'll notice it looks like a heart. You can see the double lobe shape, and that's just coincidence. And the word nebula is a term we're going to use quite a bit in the next series of videos, so let's go ahead and define it. Nebula is the Latin word for cloud. And in the language of Latin, when you add an E to the end, if it's a word with the letter A at the end, the E makes it plural. So N-E-B-U-L-A-E means clouds. So this is a nebula, and our galaxy is filled with nebulae, and that's the terminology. Now, these clouds, they're glowing for a particular reason. And you'll notice the cluster of stars in the middle of this cloud. These are hot young stars that are glowing with light. And these stars at the middle of this cloud actually formed from the cloud. So the material of this cloud is becoming the clusters of stars that we see embedded in these clouds. So these stars are the product of this cloud. And they are also very hot, and they produce ultraviolet light as well as all the visible part of the spectrum. And the ultraviolet light coming from these clouds will cause the hydrogen atoms to give off light and cause them to glow. So these young stars are energizing the cloud, causing the cloud to glow with the light that we see here. And that's why whenever we see these glowing pink clouds, we can assume that they are star-forming regions, because the gas is becoming the stars, and then of course the young stars that have formed are causing the gas to glow. So how does star formation actually work? Let's switch to a different cloud. Notice the same features. The color tells us it's hydrogen, and you can see clusters of stars inside of the cloud which are causing it to glow. The process of star formation, let's first break it down. It's really gravity that is causing all of this to happen. So you really want to keep coming back to the concept of gravity, and you'll see how that keeps coming into this discussion. One of these clouds is very big. Any of these clouds, you could say, are very big. For example, one of these clouds might have enough material to make about 1 million times the mass of the sun. In other words, you could take all of the material of this cloud and turn it into about 1 million stars, just like the sun. The size of these clouds, they're very large in physical size. Any one of these clouds might be 100 light years all the way from top to bottom, or bigger. Imagine traveling at the speed of light and taking 100 years just to fly all the way across the length of this cloud. So they're very, very physically large as well. But the one part that is a little confusing for people is, for star formation to occur in these clouds, it has to be extraordinarily cold. And the reason why that's confusing for people is because cold doesn't seem to be what you need to make what is eventually a very hot star. It seems counterintuitive. Your goal is to have a very hot star form. The first thing you need is to have a very cold cloud. So I'm going to show you why. Now follow me, this is fairly lengthy as we go through this. Let's imagine we have these hydrogen atoms inside of this cloud. Now these hydrogen atoms are moving because they do have a temperature. They're not moving very fast because the temperature is very low. Remember, temperature is the velocity of atoms and molecules. So these hydrogen atoms are moving fairly slow, but they are moving. If they were allowed to move on their own, they're all moving in different directions, and if we just let them go, these hydrogen atoms would travel in random directions, and what would ultimately happen is this collection of atoms would allow the cloud to disperse. So the movement of the atoms would force the distances between them to grow, and the cloud would get bigger and bigger. So the temperature, which is the movement of the atoms, is sort of like an outward pressure. The movement of the atoms themselves are trying to make this cloud bigger because they're trying to get far apart from each other just because they're randomly moving. However, these atoms also have mass. Admittedly, a single hydrogen atom doesn't have a lot of mass, but they do have mass and they do have gravity. And so the gravitational pull of each of these atoms is on each other, and so left to its own devices, the atoms themselves, because of their gravity, would mutually pull on each other, and these atoms would collect and get closer together. So what we really have is the movement of the atoms because of their temperature pushing outward, and we have the gravity, the pull of the atoms on each other, pulling inward. So let's blow this up bigger to an entire cloud rather than just a collection of atoms. Any one of these interstellar clouds has really an opposing set of forces. You have the outward pressure of the cloud because of the movement of the atoms trying to make the cloud steadily bigger. And you've also got the mutual gravity of the individual atoms trying to make the cloud steadily smaller. So any one of these interstellar clouds has these two opposite forces acting. And what we need is the cloud to shrink. So if you think about it, if the gas pressure is too big, more than the gravity, then the cloud is not going to shrink, it's going to grow. The cloud will get steadily bigger and it will expand. If the two forces are exactly equal but opposite, then the cloud won't shrink and the cloud won't grow, it'll just stay the same size. So what we ultimately want is the cloud to shrink. We want the force of gravity to make this cloud steadily smaller, and as it makes it smaller, it'll start to turn the cloud into stars. We need to bring those atoms together. So what we really want is so that gravity becomes more powerful than the pressure of the cloud outward. Now, how can we get this to happen? Because atoms of hydrogen don't have a tremendous force of gravity when one single atom is pulling on another single atom. So the gravity of the cloud is actually very weak. It's not able to be strong enough to really efficiently make the cloud smaller. And there's nothing we can do about that because they're individual atoms. So the only thing that can really help the very weak gravity is to make the atoms move very slowly. So if the atoms are moving really, really slowly, then the force of gravity between the atoms is now sufficient enough to shrink the cloud. So we want gravity to be very successful, and the way that we help gravity be very successful is to make the cloud very cold. So as ironic as it may sound, the places inside of these clouds where star formation is going to happen is only going to be in the coldest places in these clouds, where the temperature is so very low that the atoms are moving so slowly that their self-gravity is going to then allow them to start pulling together. So think of it as the colder the cloud is, the more we're helping gravity do its very weak work. It's very weak because these atoms are very small. Now, once the cloud begins to shrink and once the temperature starts to rise, as the cloud gets smaller and smaller, gravity starts to become more and more efficient, and the temperature can get hotter and ultimately make the cloud turn into a star. And we're not worried about cold clouds anymore. So, as weird as it sounds, star formation only happens inside of the coldest places inside of these interstellar clouds. And that is the beginnings of the process that ultimately forms into stars. And then as the stars steadily form, the clouds will start to energize and start to reveal themselves. So what we're going to do is we're going to talk about the entire process of how to go from a cloud into an individual star and then ultimately a solar system to go with it. And there's a series of steps that goes with that, and there's some physics that goes with that as well. But we're running a little short of time to be able to get it into this video. What we'll do is we'll make it our next one. So I hope you'll join me.